This is homework solution 5 video for differential equations class. So let's go over number 1, where we have to find all solutions for the given equations. So I will begin with A. Alright, so A states that y prime plus 2xy equals to x. So we should probably find the integrating factor, which I've been doing this for a couple weeks now. So it's the e to the power of the integral of the coefficient that is multiplied right in front of the y, which is 2x. So this is going to give us e to the power of x squared. Okay. Alright, so then the next step is multiply this to the both sides of our equation. So we have ex squared y prime plus 2xy equals 2 e to the power of x squared times x. The next step is integrate both sides of our equation. And I think the whole point of finding the integrating factor was that this side would work out nicely and give us e to the power of ex times y. And you can quickly check by using the chain rule. Alright, so now this is our problem. This on the right hand side, I think we can solve this probably by substitution. So let me have my u be x squared, and if I differentiate both sides, I'm going to have du equals to 2x dx. So my dx is going to be 1 over 2x times du. Now I can substitute this to our dx and our x squared as u. So we have e to the power of u times this goes in, or probably it's going to cancel out with the x that's already here. So we have 1/2 du. So this is going to give us 1/2 e to the power of u plus c. Let me just plug back in our value for u, which was x squared. So we have 1/2 e to the power of x squared plus c. Alright, we're almost there to find our y value, y by itself, so I'm going to divide both sides by e to the power of x squared. So it's gone, and I'm going to have e to the power of negative x squared. And I think that's it. So our solution, I think our textbook generally writes our solution as phi. So phi of x equals to 1/2 plus c times e to the power of negative x squared, where c is any constant. Okay. Let's go ahead and do our second problem, which is B. Again, let's find the integrating factor. Oh, before we do that, I think we need to rewrite this. So right now we have the x in front of the y prime, so let me divide both sides by x. If we do that, I have y prime plus 1 over x, y equals 2, 3x cubed minus 1 over x. So now that in this form, we can go ahead and find the integrating factor, which is going to be e to the power of the integral of 1 over x dx. And this is going to be 1 over, integral of 1 over x is going to be ln of x. And that's an absolute value sign. And because this is given, we can just ignore the absolute value sign, which now just becomes ln of x, because x is going to be always positive. And probably the rules from Algebra 2, we know that this is going to be just x. If you are, we can do a quick review. if we have e to the power of ln x, we're trying to find this. So what is this? I can apply ln on both sides. Okay, and using the log rules, this ln of x can be carried out to the front. We have, so ln of x times ln of e equals to ln of the thing that we're trying to find out. Ln of e, this by definition is 1. Right? So we have ln of x equals to ln of something. So we know that x equals to the something that we are trying to find out. So x is going to be our answer. Okay, so this ended up being our integrating factor, so let's multiply that both sides. So we have x y prime plus y equals 2. Oh, I guess the x's kind of just cancel out, so we have 3x cubed minus 1. Now we're going to do the integration of both sides. Alright, and the whole point was that our left-hand side was going to end up nicely as just x times y. Alright, so x times y equals 2. This side, it's going to be 3 over 4, x to the 4th minus x plus c. Okay. Now we're going to have to divide both sides by x so that we can have the y by itself. So divide by x. This we will have 3, and this will be 1, and we will have this over x. So if I rewrite this, we have y equals 2, 3/4 x cubed minus 1 plus c over x. And that's it. So we can say that x is greater than 0 and c is any constant. So this is our solution for part B. Let's go over to C. Alright, and this is in our form. It's in a good form, so we can go ahead and find the integrating factor, which is going to be e to the power of the integral of ex dx. So that's going to be e to the power of ex. Alright, so let's multiply this, both sides of our equation, so that gives us e to the power of ex y prime plus ex y equals 2, 3 times ex times e to the power of ex. Let's find the integral, apply it both sides. So we have our left-hand side is going to be e to the power of ex times y, and we still have this part. Take out the 3, ex e to the power of ex dx. So I think we can use the substitution rule to solve this. So let me substitute, let's say e to the x equals to u, and we have ex dx equals to du by differentiating both sides. So here we have that dx equals to 1 over ex times du. Alright, so let's plug this in place of our dx, and whenever we see e to the power of x, we can plug in u. So we have 3 integral of u, e to the power of u, and dx is 1 over e to the x du. This is equivalent to u, so we know those two things will get cancelled out nicely, so we have 3 integral of eu du. This is going to give us 3 times e to the ex plus c. Okay, so I think we just need to divide both sides by this one. So that is going to be gone, and then we have to write that. And so there we go. This is our solution. Let me just write this out. V of x is going to be 3 plus c times e to the power of negative e to the power of x, where c is any constant. All right, let's go ahead and do the last part, which is part D. Okay. So I of x is going to be e to the power of the integral of this. Don't forget the negative. So we have negative tangent of x dx. So integral of negative tangent x dx, I can take out the negative for now, and tangent of x is essentially the same thing as sine of x over cosine of x. I can use the substitution and say u equals to cosine of x, and du equals to minus sine x dx. So by this, I get to 1 over u du. So this is the same thing as negative ln of u, but we know that for u, it takes on this value. For our cosine, let me plug it back in, negative ln of cosine of x. Within this interval, our cosine is always going to be positive, so we know that this is going to be negative ln of just cosine of x. Seems like I forgot the negative value, so sorry, let's go back here. So we have, by dividing both sides to get the dx by itself, we have dx equals to 1 over negative sine x times du. So plugging this in, we should have had a negative here, and that should have given us all of these as our positive values. All right, so there we have it. We have our this as e to the power of ln cosine of x. And just like the previous problem, we know that if e is raised to the power of ln of something, we know that this is just going to take on the cosine value. All right, so this is our integrating factor. Let's multiply cosine of x to both sides of our equation. So we have y cosine of x. Do cosine of x y prime minus tangent x times y equals to cosine of x e to the power of sine x. Next step is to integrate both sides and apply d of x. So our left-hand side is going to work out nicely as cosine of x times y. This is going to equal to, now let's take a look at this side. It seems like we have to use substitution again. This time let me let u be sine of x. If I do that, then my du is going to be cosine of x dx. So dx is going to be 1 over cosine of x times du. So substituting these values, we have the integral of 1 over cosine is going to cancel out with the cosine. So we have e to the u du. And we know this is just going to give us e to the power of u plus c. And we can substitute u back in. Our u was sine x, so we have e to the power of sine x plus c. Our last step is divide both sides by cosine of x. So that sine of x and cosine of x. And that's it. So we can just rewrite our final answer as phi of x